Chapter 2, Number 7. You drive your car in a straight line at 15 meters per second for 10 kilometers, and then at 25 meters per second for another 10 kilometers. A, is your average speed for the entire trip greater than, less than, or equal to 20 meters per second? And B, choose the best explanation from among the following. So, we're going to have an average speed that's less than 20 meters per second, which probably sounds a little weird because, of course, if I just take 15 and average it with 25, and we get, of course, 20. So you might think the average should be 20, but that's actually not true because we spend more time at the 15 meters per second speed, so it weighs more heavily in our average. This, by the way, answers part B, where our answer should be that it's more time spent at 15 than at 25, and therefore we are closer to 15 than to 25. And what we're going to do now is we're going to prove this algebraically, show how this works. So let's get rid of this stuff. And now we're going to say, how long are each of these trips? We'll call the first trip trip A, that's the 15 meter per second trip, and its time, its duration, delta t, we'll say A, is going to be the distance traveled, 10 kilometers, over the velocity that we travel at, which is 15 meters per second. I'm getting that really from the idea that the velocity is, in case the average velocity, is delta x over delta t, and therefore delta t is delta x over the average velocity. I'm really not concerned about average velocities here because for each part of this trip, the speed is constant, and there's sort of a tricky thing that if your speed is always constant, then your average speed is your speed. Anyway, if we go back up here, we get 10 over 10,000 meters over 15 meters per second, which is 666.7, let's say, seconds, which rounds in the bizarre way of this being only one digit of accuracy, actually rounds to 700 seconds. In exactly the same way, the time over trip B, which we'll say is then the time at 25 meters per second, is still going to be basically the same 10 kilometers, but over 25 meters per second. So this is 10,000 meters over 25 meters per second, which is 400 seconds. And yay, it all rounds out to 400 anyway, so yay for that. Then the total delta t for this trip is going to be how long it took to go the first 10 kilometers and how long it took to go the second 10 kilometers, which is 700 seconds plus 400 seconds, or 1100 seconds. And now we can figure out the average speed by saying the average is the total distance, which is 20 kilometers, over the 1100 seconds that it took, which is 20,000 meters over 1100 seconds, which is 18.2 meters per second, which isn't the 20 that I said, but remember we only have one digit of accuracy, so this rounds to 20 meters per second. In any event, it is clearly less than 20 meters per second. You can see sort of a weird contradiction here, which is that I told you it wouldn't be 20 meters per second, and yet it turns out to be 20 meters per second, but only because of the rounding, and that's only because of the incredible insensitivity, as it were, the imprecision of the 10 kilometers, which I would say is a glitch of the problem. So let's really think that they had meant really 10 kilometers and not sort of 10 plus or minus 5 kilometers, which they could have written as the scientific notation 1.0 times 10 to the 1 kilometers, which would tell us that we have 2 digits of accuracy. In that case, we would get the following results instead of what we have here. When we round it to 2 digits, instead of getting what we had as 700, we really should get, we should really get 670 seconds. And now our delta t is going to be 670 seconds plus the 400 seconds, which is still really, would still be 2 digits now. So these would really be, with our correct precision, 6.7 times 10 to the 2 plus 4.0 times 10 to the 2, all as seconds, which turns out to be 1.1 times 10 to the 3 seconds, or again 1100. But now when we do our division and we say that the average velocity is 2.0 times 10 to the 1 kilometers over 1.1 times 10 to the 3rd seconds, which would be 2.0 times 10 to the 4 meters over 1.1 times 10 to the 3rd seconds. This turns out to be 18.2 meters per second, but now we round to two significant figures and we get 18 meters per second, which is clearly less than the 20. So it's sort of a weird glitch in the way the problem was set up. I think that Walker was a little unprecise, a little bit careless about how he specified precisions. If you'd only take it to one digit, the answer is in fact 20, but that's actually hiding the truth. It's really always going to be somewhat less than 20 because you spend more time at 15 than at 25.